Hi again. So welcome again to this channel and today's paper is neural data driven captioning of time series line charts. The paper is proposed by Spreafico et al. In AVI 2020 and this paper is like we have seen a general image captioning problem. What is image captioning problem? Given a natural image and have to generate its corresponding text that what is happening in this image. So here multiple models you can use for this image captioning task. Basic one is with RNN, CNN with the RNN. So this is like this is image in which what is happening, a group of people shopping at an outdoor market, and there are many vegetables at the fruit stand. So these all the captions what this image can generate from this and into a textual form. So this is a general problem of image captioning, but when it comes to chart or chart images, so the what will how it will be similar to that. So here this is also an image, and what is happening in this image, total vehicle entering Canada uh, in 2018. So this text corresponding to this image chart will become a captioning problem. But in this paper, what exactly is happening? This caption is generating, that is no doubt. But with this, how this chart is generating and from where uh, this caption is generating. So for this, uh, first chart is generated using the time series data, and this caption is also generating from similar data for this time series data have been generated. So here in this because no data is available for such kind of task, so they um, they have they have created their own data set. So data set contain 100 line charts, 306 captions, and average length of each caption is 53.26 word. And they have also considered two baseline for this, bigram baseline and similarity model. So we'll also look at that. And also this main model is proposed in this paper is encoder decoder LSTM neural model. So let's see this methodology in deep, how this paper is trying to solve this problem. Here the main thing is of encoder decoder model. So in this the main difference of from the other LSTM model with this LSTM model is like is cell. So these cells are spatial because of it can carry relevant information throughout the processing of sequence. So even if even information from the earlier time step can influence the later time step. This reduces the effect of short-term memory. So this is one of the best advantage of doing encoder decoder model with the cells. So in final, the softmax anti-tokenization process allow to obtain the output word WT. Also, and also here, if you want to if you want to know its methodology, then yeah, definitely. Other processing is similar to that of LSTM models. If you want to know about LSTM models, there are a number of videos. I'll also make one video for that. So there's nothing too much special for this in this case, only apart from these cells. So advantage of doing this kind of model, advantage of doing this is kind of model is that the input and the output sequence can be different length, and also but it have everything have some limitation and can extend to further things. So it's limitation like data driven approach, also like this chart as well as this caption is generated from time series data. It can also solve for real chart images. And uh, also this is overlooked aspect of doing this kind of problem. So need to apply more complex deep learning architecture to get the better results, also more complex data set for doing this kind of task. So this is all about this. And yeah, I discussed here that there is two baselines also. So let's um, see what is this bigram model here. So we know that in n-gram model are basic language model first. So making that that make n-gram model make assumptions that the probability of a word only depend on the previous word n. So but here, so this is also somewhat similar to that, not exactly similar, because in n-gram word is depend on probability of word only depend on the previous n words. But in bigram they used the first word w1, the first word any, I mean, let's say w1 is sampled from the conditional probability, and also conditional probability, and then start with. So I think there is one paper in, uh, for which you can understand better. So yeah, this. So here let's see mm, two baselines. Yeah, that's what I'm talking about. So n-gram is a basic language model making the assumption that probability of bird depend on the previous word. Also in bigram case that they use in the baseline, first word w1 is sampled from conditional probability of probability of pw given that s, where s is the start of sentence. So next word is based on only a previous word, not a previous n word, right? So yeah, it's only depend on these previous word. Then the next word is sampled from w2 given w1 and w3 given w2 and w4 given w3 and so on. So getting the difference between n-gram and bigram, the n-gram or probability of any word depend on all the previous words, but in bigram is only for two things. First, what you are finding based on the only the exact previous thing. This process continue until the end of the sentence character generated for a sentence generation, and until the end of the caption character is generated for caption generation. So notice that this naive baseline does not consider the time series value at all. Okay, but exclusively bases its output on the vocabulary is word conditional probability learned from the training set. Okay, so that is also fine. So now getting what no this bigram model. Also, they have used this similarity model. So let's look at that also. In contrast to bigram model, the similarity model does consider the time series value. Okay, so what was problem with that? It does not consider the time series value at all. So here there is a benefit of doing bigram, benefit of doing the similarity model, because in bigrams it wasn't able to consider the time series data. So in similarity model does consider the time series values as an input. Okay, so in fact inspired by the nearest neighbor algorithm tries to I hope you all know the nearest neighbor algorithm. So it tries to match the input normalized time series with the most similar one within the training set. Similarity is calculated using Pearson coefficient, and which measures a linear correlation in the range +1 total positive for a total positive correlation, and -1 for total negative correlation, and 0 indicating there is no correlation between those two words. So one of the most similar time series TS has been identified that the associated captions are used for generation. More specifically, one of these captions are randomly selected and then and the generated predefined tokens that it contains are filled with the corresponding information from TS input. So similarity input process is applied to generate a single sentence by randomly selecting the sentence from the caption associated with that TS similar is fitting its generic token appropriately with the information from TS similarity. So this is all about the similarity model. So here one more paragraph is for encoded course. So let's quickly go through that. This is standard neural model composed by two LSTM and encoder and decoder. Okay, that in big diagram we have seen that. And here this diagram, we have seen this. Yeah. Okay, so this diagram we have seen this, and this is okay. So all right, two models by two LSTMs. One is for encoder, one is for decoder. The core concept of model is the cell state, which carry the relevant information throughout the processing of sequence. So even information from earlier step or time step can influence later time step. Okay, so reduce the effect of short-term memory. One of the main advantages of doing of this kind of model is that the input and the output sequences can be of different length, right? This is also another disadvantage of doing that. So as on figure 3, just seen before, the encoder LSTM accept as input the sequence of values xt of time series and produces its output of vector of features called encoder vector. Okay, so this we know as input we have to as input we have to go some kind of vector in the form of vector, and uh, output it produce a vector of features called encoder vector, which is fed into the decoder. And the LSTM decoder predict an output st at time step t, which were applying the function of softmax functions and the tokenization process. So this allow to obtain this output over WT. So finally, in order to let this model be able to generate either a single sentence or a four captions, so they introduce a specific tokens to indicate the start and the end of the either sentences or a caption. So this is the main things about that. The paper, it's a nice paper. If you want, you can go through that. So not a long paper, it's short. It is a short paper of total of 5 pages. So that is for methodology and all this in 1 or 2 pages. So it's nice to go with this paper, and definitely you'll get a lot of information about that. So thank you for joining me again, and thank you also for your like, share, and subscribe.